Something's wrong. Here we go. All right. So on 7.1, dilations. Recall last semester we learned about 3 different transformations. We learned about this one, which is a reflection. This one was a translation. And this happy fellow right here was a rotation. Now, just like before, remember we had that specific notation. In this case, we have, remember, we would have something like capital letter R for a reflection. Yeah, you're not sharpen it, but yeah. Okay. And you can have something like over the x-axis. Okay, or remember reflection. This would actually be y equals negative x. This translation would be represented with a capital T. And remember, we'd have like these vectors here, and this would be 7, -3. And this rotation would be represented with lowercase r, and this would be 90 degrees about the origin. Now remember, if 90 is positive, is that clockwise or counterclockwise? Who remembers? 50-50 shot. Take a guess. Clockwise or counterclockwise? Clockwise or counterclockwise? Yeah. You're saying it's clockwise? Close. It's actually counterclockwise. Remember, positive is counterclockwise, negative is clockwise in this case. All right, so just a refresher there. All right, so anybody still writing this down? If you are, please let me know so I don't clear it. I'm going to have to clear it because it's dragging. All right. So these transformations were called rigid motions, meaning the size and shape did not change. All those angles were preserved. All the sides were preserved. It just kind of moved it around, okay? However, today we're going to talk about non-rigid motions. Non-rigid is going to mean that the sizes and the shape, definitely the sizes can change, okay? So in this case, we're going to discuss a dilation. And this is a transformation that changes the size of a figure, but not its shape. So in this case, you can double it. You can reduce it down. How many of you ever went in for an eye exam? How many of you have ever had your eyes dilated? Where they kind of like put drops in and your eyes get really wide and they have you wear sunglasses? Do you guys ever do that? No? This is kind of part of it. What they do is they take your eyes, they'll put some drops in, and it'll relax the muscles in there and widen like the black in your eyes, and it'll widen to like triple its size. And because your muscles are relaxed, they have you wear sunglasses so that this way, when the light hits, it doesn't like try to contract and it won't cause blindness. All right. So in this case, we have, it changes its size by a scale factor of, we're going to call this, I don't even know what they wrote down there. I guess scale factor of N or H. Okay. Oh, it's N in this case. They did N. Okay. Never mind. It's N. If N is greater than 1, okay, or the dilation is an enlargement. If N is between 0 and 1, we're going to say it is a reduction. Questions on this? All right, so it says rectangle A prime, B prime, C prime, D prime is a dilation of A, B, C, D. So I am going to label these. In this case, this is our pre-image, this is our image. Remember, the primes always represent what's happening with it. Now, if we take a look at this, you should see, it says, what do you notice about the angles of the image and pre-image? In this case, they are congruent. Angles determine shape, so those should not change. Okay? It says, what do you notice about the sizes of the image and pre-image? In this case, if you look, it's getting larger. And lastly, is the dilation an enlargement or a reduction? In this case, it'll be an enlargement. Can someone give me an example of an enlargement that we see every day in life besides the eyes getting dilated? You might not even be aware of it, but I promise you, they are around. More to come on that then, I guess. Think about it. If anybody can get me an example of an enlargement in everyday life, I'll give you an extra credit point. Okay, so in a dilation, okay, angles are congruent. And the side lengths are larger or smaller. Okay. Now, there's a little bit of notation I want to go over with you guys real quick. We're just going to kind of put this on the side. The notation for this is going to be that, and this is what you're going to want to write down. I'll tell you that much. Capital letter, we're going to call it capital letter D. We're going to put a 3 here, and then we're going to state A, B, C, D. So we're talking about taking the dilation, okay? This is an enlargement because this 3 right here is our n, so that's scale factor that we're multiplying it by. And this is the figure. Or in this case, your pre-image. Image, point, what have you. So in this case, if we take a look at this, we're going from 1, 2 to 1, 2, 3, 4, 5, 6. That means we took this size of 2 multiplied by 3 to give us that enlargement of 6. Same thing with CD. We had 1, 2, 3, and if you count here, you should have 9 spaces. Okay? So this was enlarged by a scale factor of 3. If it would be a reduction, it would be something that is between 0 and 1. So you'd have a fraction there or a decimal. Okay, like 0.3 or 1/3. Okay. Questions on that? But that is the notation. All right, so our scale factor is usually found by the image over the pre-image. So you're going to want to star that. In this case, I would take, so that's, oh, it's right there, sorry. So for the scale factor of the dilation above, now it's the image, so that's the larger one. Again, I would take that 6, I would divide that by 2, giving me my n is equal to 3. So that's where the n comes from. Anybody still writing? Or any questions on this before we move on? All right. This rectangle W prime, X prime, Y prime, Z prime is a dilation of W, X, Y, Z. So again, I'm going to label this. This is my pre-image. This is my image. So looking at this, this is a reduction. So it says, was the dilation an enlargement or reduction? Is a reduction. That's easy enough. What is the scale factor? So I take the image, which I have 2 spots, and I divide it by, you see, XY, I'm going to look at XY here. 1, 2, 3, 4, 5, 6, which means my N is 1/3. And how would we write this notation? We would do capital letter D, 1/3, and then we would have X, or I should say WXYZ, sorry. WXYZ. All right. So what I want you to do is, real quick, I want you to do the you try it right here. Give this a shot. Identify your image and your pre-image and your image and answer all 3 questions. Go ahead. All right, show of hands, who's still working on this? Okay, big reveal. Okay, so this is what you should have gotten. It's a reduction. N, or you can call it your K value also, is 1/2. And the notation would be the dilation with a scale factor of 1/2 of triangle ABC. Questions on that? Okay, let's take a look at our next page. What if we are given the coordinates of the pre-image and asked to use a scale factor to find the coordinates of the dilation? All right, so for part 4, what we're going to do here is we're going to have to multiply each point by our N. Delta Math calls it K, okay? But it means the same thing. All right, so find the coordinates of the vertices of the image. So we're talking about a dilation with a scale factor. So our N is equal to 3 of X, Y, Z. Now they're giving us the pre-image points. I have X as 3, 0. I have Y as 4 comma 2, and I have z as 6 negative 2. Now for multiplying each by 3, that's going to look like the following. My x prime is going to be 3 times 3, and then 0 times 3, which gives me 9 comma 0. So there's my new point. We're going to have y prime, which is going to be 4 times 3, and then 2 times 3. So I'm just multiplying each by 3. This is going to give me y prime is 12, 6. And then we do the same thing for z prime. It's going to be 6 times 3, comma, negative 2 times 3. 6 times 3 is 18. And then negative 2 times 3 is negative 6. Now, if it's a fraction, use your calculators. Put the parentheses around the fraction and multiply by each individual number. In fact, take out your calculators. I kind of want to show you what's going on with that. Whoa. Ooh. Hold up. Okay, so for this next one, it says, what are the coordinates of the image D.56, comma 10? In this case, they're not giving you the whole thing. They're giving you just part, okay? They're just giving you that one point. So in this case, all I'm going to do is I'm going to take 6 and multiply it by 0.5, comma 10 multiplied by 0.5. Why don't you guys tell me what you get there? What do we get? Half of 6 is, yep. And 5. There you go. All right, so that's just if you're given 1 point. All right, example 6. Now this is actually going to have that, it's going to actually use the fractions. Uh-oh. Well, I'll show you guys on, I'm trying to get my TI calculator up. It's not working. I don't know why. I installed it. I'll try one more time. Okay, whatever. So in this case, it says we have these points, right? So our pre-image, they're saying use triangle PQR. So our pre-image is PQR. Now our first step here is to identify the points. So if I look at P, it looks like I have 8, 4. If I look at Q, I have 10, 11, it looks like 12, negative 4. And R is going to be, looks like negative 4, 0. Okay, so what they're saying here is we're going to first, what are the vertices of the dilation of 1/4 of triangle PQR? So the first thing we need to state is, first off, this is going to be a reduction, so it's going to get smaller, all right? So if I wanted to find this in my calculator, So I'm just going to use p prime as the example. I'm going to take 8 and multiply it by parentheses 1 divided by 4. And then the next part, I'm going to have 4 times 1 over 4. In the end, what is p prime going to be? Who can tell me? What are points for p prime? Eight times 1/4 is? Anybody? To hear, what's 1/4 of 8? 2. And then what's 1/4 of 4? 1. All right, so there's our p prime. Q prime, if we did the same thing, is going to be 3, negative 1. And R prime is going to be negative 1, comma 0. Now, if I wanted to, I can graph these, and I would, because on your homework tonight, you're going to have to anyway. So p prime is at 2, 1. So there's 2, 1. There's my p prime. Q prime is going to be 3, negative 1. And R prime is going to be negative 1, 0. So here is what my reduction looks like. Okay. Questions on that? I want you guys to do the you try it 1, 2, 3. That's at the bottom of this page. I'll set a timer, let's say 6 minutes. Oh, and just an FYI for you guys, this is a very short topic. It's only got like 4 or 5 lessons in it. So your test is probably going to be Thursday or Friday next week. We're not going to be having a quiz. Bless you. So just make sure you're paying attention. And remember, this is still status quo. You have until I get into the grade book, but I'm not going to lie to you guys. I got a lot of time on my hands right now. Huh? Yeah. But just remember, Luis, what I told you at the beginning of class, once that new system's in. Wait, did they take that whole bunch of pens that were up there? There was like a whole box of pens. Okay. Oh. Show of hands, who's still working on the You Try It? All right, let's check it out. All right, so here's 1 and 2. Check your answers for that. Let me know what questions you have. All right, questions on this. All right, here's Try It 3. Check that out. Let me know what questions you have. Now look at this. This has this actually has decimals that you're dividing. Please make sure that you are dividing these appropriately. All right, because you could still get whole number answers after. Questions, comments, concerns? Anybody still working on this? Okay. Take out your computers. You're gonna have a Delta Math tonight. I just want to make sure it's going through because I've been having problems with the new semester stuff. I think it's working now, but I don't know. Those of you watching at home, have a great day.